video, a champ athlete is punting a football from the 40-yard line all the way to the 10-yard line on the other side. From this video, we could see that he had punted the ball from the 40-yard line. We could also see that the ball had hit the 10-yard line on the other side. From the clip, I was able to construct this diagram. I could conclude from the video that it took 3.3 seconds from the time he punted the football to the time it hit the ground on the other side of the field. We could also see that there were 50 yards between the 40-yard line on one side of the field to the 10-yard line on the other side, and this 50 yards equates to 45.72 meters. The athlete's initial position was 0 meters. The one thing we are not given, however, is the angle. This is the equation I used to find initial velocity. Our givens are x equals 0, v0 is not given, time is 3.3 seconds, acceleration is negative 9.8 meters per second squared. After plugging in our givens into the equation and isolating for v0, we get v0 equals 16.17 meters per second. From the video itself, we aren't given vx or v initial y component, so in order to solve for theta, we must solve for v's first. In order to solve for vx, we did distance over time, distance being 45.72 meters and time being 3.3 seconds. This gave us 13.885 meters per second. Next, I had to solve for v initial y. To start this, I started with the equation time equals v final y minus v initial y over ay. V final y could cancel out to 0, and that leaves me with negative v initial y equals time times acceleration of y. Plugging in numbers, I could do 3.3 seconds times negative 9.8, which is the acceleration of the y component, and solving this gave me 32.34 meters per second. In order to solve for the angle, I used my tan inverse equation and got tan inverse of 0.428, giving me 64.66 degrees. To find v initial x component, we did v initial cosine theta, giving us 6.9 meters per second. To solve for v initial y component, we did v initial times sine theta, giving us 14.61 meters per second. This diagram is a reflection of the football's projection. The max height occurs at the vertex of the projectile's parabolic motion. Vx at the max height is always the same as any other place on the parabola, so it's always constant. Vy at the max height will always be 0. The velocity of the projectile at maximum height would be the sum of those two, so 6.92 meters per second. In order to solve for max height, I used the equation v0y squared for 2ay, giving me 53.36 meters. Something else we needed to solve for was the time that the projectile spent in the air. To do this, I used the equation t equals v final y minus v initial y over ay. Our final velocity of the y component was 0. Our initial velocity of the y component was 32.34 meters per second. Our y component's acceleration was negative 9.8. It's negative because the projectile was going downward. After plugging these numbers into the equation, I got 3.3 seconds. Impact velocity is the resultant vector of the vertical and horizontal impact velocities. We can create a right triangle using these vectors and solve for the impact velocity vector, as it is the hypotenuse of the triangle. Solving this gave me 14.28 meters per second. Here is a free body diagram demonstrating the motion of our football. We can see that there is a force of gravity acting on the object. The vertical acceleration is also known as negative g, negative 9.8 meters per second squared. It's negative because it's going downwards. The horizontal acceleration is 0 because there is no force acting horizontally on the object. There is only acceleration in the y direction, so ax is 0. This shows the displacement components of our projectile. Because the ball started and ended on the ground, our dy is 0, and our dx, however, is the displacement the ball went horizontally, which was 45.72 meters.